Before watching this video, make sure that you do watch the video with the animation comparing the two windmills, as it really helps to visually see how the windmill features affects the sinusoidal curve. In this video, we are actually going to find the equation that models the path of the windmill, and then find another equation once we change one physical feature of the windmill. So part A tells us that windmill A spins at 20 seconds per revolution. It has a tower height of 100 meters and the blades are 40 meters long. We are asked to determine an equation that models the height of the blade tip starting at the maximum height. So the first piece of information in the question is that the windmill travels at 20 seconds per revolution. So right away we are told the period that it takes for one cycle. The period is 20 seconds. So once we know the period, we can easily find the B value of the equation. Remember the formula, B equals 360 divided by the period. So 360 divided by 20. So B is 18. This actually means that the windmill rotates 18 times in 360 seconds. The next piece of information we are told is that the tower has a height of 100 meters. So the tower is the base with not considering the blades. So that would be this height here. The blades rotate around the top of the tower. So the maximum is the length of the blade above the tower, and the minimum is the maximum blade below the tower. So the height of the tower is actually the midline. And the midline we find from the V value. So once we know what the midline is, we know what the V value is. So the midline is 100 meters. So we know that the V value is 100 meters. There has been a horizontal shift 100 meters up. Next, we are told that the blades are 40 meters long. So that is the length of one blade above the midline and then below the midline. So once we're at the midline of 100 meters, the maximum that the blades could go is 40 meters above that. So 140 meters above the ground. The minimum would be 40 meters below that, so which was 60 meters above the ground. So knowing how long the blades are tells us the amplitude of the function. We are also told that we want to start the model at the maximum height. So when the blades reach that maximum height is when we start to draw the curve function or model what is happening. So I'm going to highlight that. That is a maximum. When a scenario starts at a maximum or minimum value, it is best to model with a cosine function. If the scenario starts at the midline, then it's better to use a sine function. But often in word problems, we do start at a maximum or a minimum. When we start at a maximum, there has not been a reflection in the x-axis, so that means our a value is positive. When we start at a minimum, the a value would be negative. So here we're going to say h is equal to 0 because there's not a phase shift, because there is a maximum at the beginning when time is equal to 0. And because there's a max, that means the a value is greater than 0, so it is positive. So now we have all the information we need. So we're modeling height, so we'll use h instead of y. The height is equal to the a value of 40, when we said that that is positive. We chose a cosine function. The b value is 18, and the height is based on the time. So 18t, we know the h value is 0, so we don't have to write that in. And then the v value is 100. And again, I used the variables h and t because they're more representative of the application problem that is happening here. In part B of the question, we have windmill B. We are told that it spins at 12 seconds per revolution, but the other features are identical to windmill A. And now we're asked to determine an equation. As only one feature is changing, that means only one parameter is changing, either A, B, H, or V. So now we just need to decide which parameter it is. We are told that the windmill is now spinning at 12 seconds per revolution. So it's spinning faster than windmill A. So that means the period is changing, which affects the B value. So only the B value is going to be affected by this change. So that means all the other parameters are the same. A is still 40. It's still positive because our H value is still 0 because we're still starting at that maximum. The V value is still 100 because the tower is not taller. Now B is just 360 divided by 12, which is 30. So that means in 360 seconds, this windmill is going to rotate 30 times instead of 18 times like it was in part A. So now we can just make the equation. Therefore, the height is 40 cos 30t plus 100. So we can see that B is no longer 18, now B is 30, but all other parameters are the same. And then just taking a look at the graph that compares the two windmills in this situation, we can see that both windmills have that maximum height at time 0. So that's why we have that phase shift of H equals 0, because they're both starting at a maximum. We can see that their midlines are the same because they both have the same tower height. So you might want to draw that in. You can see that the maximums are the same and the minimums are the same. So the amplitude is also the same. But because windmill B spins faster, there's more cycles in the same time period. And we can see that windmill A, to go from a maximum to the other maximum, takes 20 seconds because the period is 20. Whereas windmill B, to go from a maximum to the next maximum, only took 12 seconds.